For this example, we're going to find the intervals for the functions increasing, decreasing, and constant. Now, intervals, that's the intervals of x, so we're using x values only. Now, for most books, anytime we do increase, decrease, and constant, we're always going to use parentheses, no brackets. So, what we're going to do, here's what increase, decrease, and constant means. Increase, you always read a graph left to right. Left to right. So increase is where it goes up, decrease is where it goes down, and constant is where it's not going up or down but staying horizontal. Now looking for, and these are the y values, so in a sense what you're looking at, you're looking for the x values where the y values go up or down or stay constant. So let's look at this graph that's given. Now once you look at it, it's going up this direction, and then it starts to go down, and then it stays constant, and then it goes up, and it stays constant again. That's the basic idea of this problem, or this graph. Now since we're looking for x values, that's the only thing I'm going to label. So for this point, the x value is -7. I don't care about the x value. Now this point, it is, looks like -5. Now for this point it is -2. For this point the x value is -1, always doing the x value. So those are the main points I'm going to use. So what you can do is you can like divide it up to where it starts shifting from increase to decrease or constant. Do you see this? So let me just erase all this, and so you can see a little bit better. How do you like that? Probably don't. So here we have a point, a place where it starts to change directions. Here it does too. Here it does also. Is that crazy or what? And here it does also. So here we go. On this part it's going up, so it comes from where? -infinity. We're assuming that the graph never does stop because of the arrow. We know it doesn't then. So that's an increase. So I'm looking at the increase. So that's -infinity. And what is that x value? Once again, it is the x value. That x value, if you want to label it, is -7. I'm never using the y values on these. Close that off. And then this one, it's going down. And so that's from there to there. Well, that represents -5. See that? -7 to -5, it's going down. So that's a decrease. Always using parentheses. And then there to there, that looks like a -2 once again. So from there to there, it's constant. So from -5 to -2, it's constant. And then you see this green line, and we have a -1 for that one. So between -2 and -1, it's going back up again. That's an increase. -2 and -1. We'll just use a comma between them, or U. I think this book probably uses a comma. And then from -1 to forever, it's constant again. So -1 to infinity. And that's it. Now, you may want to see me do that a little bit better. I think I'm going to, just because I can. So I'm going to use a red line here. I have to put the colors, a blue line here, and a green line here. And then I don't know what color this is. Ooh, gray. Ew. And I'm just going to label those numbers. So that was a -7. That one was a -4 or -5. Get them right, Eric. -5. And then this one looks like it's a -2. And then this one was a -1. That's the x values, where these lines are crossing the x-axis. So that's why I only have those numbers besides infinity, of course, and -infinity. So negative infinity to 7, negative 7 is going up, negative 7 to negative 5 is going down, negative 5 to 2 it's constant, negative 2 to negative 1 it's increasing again, the negative 1 to infinity it's constant again. Colors kind of make it neat. Let's look at this example. We're going to find the domain and range of the given graph. Now, the domain is the x values left to right, and the range are the y values down to up. So what I want to do, I want to label this point. That point looks like it's negative 5, negative 7, comma 1 to negative 3. Now this point looks like it's 5, 6, positive 7, comma 1. And then the two top points looks like that one could be 1, comma 4. And this one looks like it's 3, comma 4. So on the domain we're looking left to right, so looking at the farthest left x values, it looks like it's a negative 7, and this farthest right x values is 7, positive 7. But those dots are shaded in, so that means that we're going to use brackets. Now for the range we're going down. What's the lowest y value? The lowest one I see is this negative 3. Remember that's an x and that's a y. That's an x and that's a y. So that y value is the smallest one, the lowest one. So that's a negative 3. And the highest y value, well, both of these have a 4, so I need one of them, 4. The dots are all shaded in, so I'm going to use brackets in that case. Bracket looks like a weird looking bracket thesis. That's just a bracket. We're done. On this one, we're going to identify maximum min, that's just maximum minimum over a certain interval. And we're going for intervals where the function is increasing and decreasing. Now, when you do maximum minimum, that's the y values. So when you see it like this, the relative maximum, well, these are going to be the y values. These two answers will be. So the max is where it's the top of this point, and the min is the bottom of that point, the y value of those points. So if you look, this is a maximum. So that y value at that point is negative 1, at the x value negative 5. Now this point is like in a valley. If it's a maximum, you're on the mountaintop. Minimum, you're in the valley. Sometimes you're on the mountaintop, sometimes you're in the valley. And so that y value is negative 33 for the minimum, and the x value is a positive 3. Now we're looking for increase and decrease. I'm going to erase this to get that out of my way. For the increase and decrease, we're looking where it's going up and where it's going down. And we're looking for x values only. So what I'm going to do is I'm going to mark this off. Oh, I missed it. I missed it bad. I missed it bad. So it looks like that's a negative 5. So if I can draw a line, straight line through it, yeah, that's not too bad. And we got another one here. I'm actually going to do is I'm actually going to label those. So I'm only looking at the x values. We need to increase and decrease. X values only. So that's got an x value in a negative 5, and that one's got an x value of a positive 3. So what's going on is this is coming from negative infinity and it's going up. And that's from negative infinity to this x value, which is negative 5. So that's, I'm just going to do it on the side or on the bottom. So we have increase from negative infinity to negative 5, and then between negative 5 and 3 it's going down, so that's a decrease. And then from 3 to forever, which is infinity, it's going back up again, and so that's an increase. So let's match up our answers. Negative infinity to negative 5 and 3 to infinity is D, and then negative 5 to 3 is A, and we're done. For this problem, We're actually going to graph this function. Notice that the basic function is the absolute value of x, which means the shape is going to be a V shape. Now, if you want to understand the shifts, you can rewrite it like this, which means that that plus 6 is going to move it up 6, and then that negative that's on the outside, because what's going on is your basic function is y equals the absolute value of x. That means that that negative is taking all those positive y values and flipping them upside down. So instead of being up here, they're going to be down here. So that means it's going to be flipped over the x-axis. So if you flip over the x-axis and then you move it up 6, it should look something like this. And I'm not going to worry too much about being totally accurate. I just want a basic idea of how the function looks. Now you can also type in your graphing calculator. So let's go to y equals. I'm going to type it in the way it's written, 6 minus absolute value of x. I like to find the absolute value underneath the catalog key, which is second 0, and you'll see the ABS, which is the first thing. Enter, and then the x, and then graph, and you'll see that. So everything looks pretty accurate. So what I'm going to do now is I'm going to look at these problems, and the problem is asking to determine the intervals where it's increasing, decreasing, and any max or min. Now the first thing I want to do is find this point. Well, since absolute value of x starts at 0, 0, when you just moved it up 6, that means that that point is 0, 6. 0, 6 is all that what that point is right there. And I'm going to use that to answer all these questions. Where's it increasing? I may not scroll down, but that's what all these parts are asking. Increasing. Well, remember, if you've seen previous videos or if you've seen this before, what I'm going to do is I'm going to mark this off right in there. And what that is, if you look, it's crossing the x-axis at 0. So that's our x value we're going to be looking at. So on our increase and decrease, we always go from left to right. So from the left, which means it's coming from negative infinity, it's going up. See that? So it's increasing from negative infinity to that x value, because when you do increase and decrease, you only do x values. And that x value is 0. I always use parentheses also. And then it's decreasing from that x value, which is still 0. And then how far right does it go? It goes forever to the right. So we use infinity. Now we're looking for max and min, relative max and min. Now relative max, which I'm going to scroll down just a little bit so you can see how it looks, how it's going to ask you. It's going to say has a maximum or minimum at, you stay what the y value is, it's a y value, at x equals so and so. So let's just go back up here. Well, this has a max because it's a max looks like this, a min looks like this. So there's no min because there's nothing looks like that. So the max is actually y equals 6, or just 6, at x equals 0. And that's how these kinds of problems, the way they're set up, they'll want you to write it like that. So I just want to leave off the y, just say at 6, or is 6 at x equals 0. And then we have the graph on our screen. It doesn't have a low value, a valley. And so you just pick B part that doesn't have one. And that's how you do. Looking at this problem, it's asking us to use a graphing calculator, which I'm using the TI-84, to graph this function on this view and rectangle, which we'll take a look at it. And then we're going to look for an increase, decrease, and any max or min that may exist. And I'm going to use a calculator to be very specific if I need to. So let's go to y equals, because anytime you see f of x, that's the same thing as y. So it's y equals a negative x. Now how you do the cube is totally up to you. You can look on the math key or just use the caret key to 3, and then use the right arrow key to bring it back down. Plus 6x, I'm going to use the square over here, minus 9x minus 3. And I'm going to graph it. Now the reason why it may want you to change the view in rectangle so you can have a more accurate view of this. So let's go ahead and just change it and see if it really helps us any at all, and it may not. I'm not changing the scales, by the way, nor does it say change the scales. So if it doesn't say to change the scales, I'm not going to change the scales. Okay, so that's how it looks. If I go back to my normal window setting, zoom 6, I can still see it. So there really was no reason to change the view in rectangle unless you just want to be more accurate. But I'm going to be extremely accurate because there is a way to be extremely accurate. Because what I need to do, I'm going to look at this graph. I'm going to just draw a variation of it. That's terrible. What kind of graph was that? Just make it a little bit better. Like this. That's horrible, but we're going to use it anyway. Notice I don't care about the x-axis or the y-axis. All I'm going to do, I'm going to find this point. I'm going to find that point. So to do that, I'm going to go to trace. Above the trace is calculate, and that's blue. So hit second trace, and then I'm going to do the maximum first, which is 4. Now I'm going to do this is the maximum right here. This is the maximum. So what that means is I'm just going to take my right arrow, left and right. Don't use up or down. And just go over there and keep it to the left somewheres. I don't want it over there because that has a min. I don't want a min inside of a max. So I'm going to move it over to the left, close to that maximum point, maximum value. Hit enter. Notice that arrow that pops up. And then I'm going to move to the right because that's for a right bound. That was kind of strange how that happened. Did you see that? That's kind of cool. Hit the right arrow and hit enter. So I have my bound. Those two bounds, my maximum value is going between those two bounds. Guess I just hit enter again. And it looks like anytime you see a number like that, that's actually a 3. So let's use 3 comma negative 3. Now let's do that second trace again, calculate key, this time to the minimum, which is 3. So I'm just going to move it over to the left, hit enter, move over to the right, hit enter, then hit enter again, and that's the same as the 1. So we're going to get 1 comma negative 7 for that point. And in all actuality, I am done using the calculator, so keep that in mind. So here we go. We're going to find the intervals where the function is increasing. Well, it increases from this point to that point. So I'm going to draw my blue lines that you've seen in previous videos I like to use. And that I'm using x values. When you do increase and decrease, it's x values only. So the x value there is a 1, and here it's a 3. So from 1 to 3, it's going up. So that interval is a part, and we always use parentheses. And then for the decrease, that's where we're going to go down. So I'm going to take my eraser and I'm going to erase that. I hear a phone ringing. Hopefully you don't hear my phone ringing. Oh no, I erased everything. But that's okay. We still have the graph. So we're just going to draw it again. We can always do this. Watch this. We're going to bring it back up. I want to make sure I keep everything in there, because I just want to erase the blue lines. That one, that one, that. Oh, bad. So let's just keep that. Now, I'm going to use green. I'm going to draw those back in. The decrease is going down. So it's going down in these two areas. So in this part and in this part is it going down. And so once again I'm using those x values, but this time it's coming from negative infinity, that's to the left, and then to the right it goes forever positive infinity. So basically what that's saying is that when you find the decrease, you're looking down. So it's coming from negative infinity. And what's the x value there? The x value is 1. So that's one interval. And it's also coming from 3. And it's going down forever to the right, to infinity. And so that's C part. Now I'm going to erase all this because it's actually getting in my way a little bit. Or maybe I won't. I'll just keep it. We'll look at the graph on the calculator. So, I'll just go ahead and draw that again. I did a quick sketch down here. Whee! I remember what those points were. This one was 1, negative 7. This one was 3, negative 3. Yeah. So, remember, maximums look like that, minimums look like that. So this one has a maximum. We want the y value, which is negative 3, at the x value of positive 3, because that one is a max. This one. And then this one is a valley, which means it's a minimum. So it's the y value, which is negative 7, at the x value of 1. Hopefully you can read through my colors, but that should help you get an idea anyway. What we're looking at on this example is a piecewise function. It's just a function that's broken up into two different pieces. Now if you look at the for part, that's a restriction on the domain. So that means we're only going to look at x plus 2 if our x values are less than or equal to 1. We're only going to look at 9 minus 6 if our x values are greater than 1. So we got three different function values we're going to find. So start with g of negative 1. Now the negative 1 is the x value. And since negative 1 is less than 1, we're going to use x plus 2 to find the value for g of negative 1. So we're going to use an x plus 2. We use negative 1 plus 2, and negative 1 plus 2 is 1. Now let's find g of 1. 1 is the x value. Since 1 is less than or equal to 1, we're going to use x plus 2 again. So 1 plus 2 is 3. We're just substituting. We just got to decide which equation we're supposed to substitute. And that's where the domain restriction helps us. G of 6. 6 is the x value. 6 is greater than 1, so we use the 9 minus x equation. So 9 minus x, in this case x is 6, 9 minus 6 is 3, and that's it. For this example, we're given a piecewise function, and we're going to find four different values. And notice the piecewise function has three different parts, or pieces. Now, this part is the domain restriction. So what this is saying that is all the real numbers less than negative 6, but negative 6 is not included. So if you want to see like interval notation, it'd be like that with parentheses. Now for this piece, the negative 6 is included, but the 5 isn't. So we use parentheses around the 5 and bracket around the negative 6, because it's saying that x is between negative 6 and 5, but negative 6 is not included. Or the negative 6 is included, but the 5 is not. So that's why we have brackets and parentheses. And then for this piece, we have where x is greater than or equal to 5, so we can use a bracket around the 5 and then forever to infinity. So when we're asked to find h of negative 6, we're looking for the domain restriction, or in this case the interval, where negative 6 exists, and it exists in this region, or for this piece. So what we have is a constant y value of 5. So what that's saying is that for any real number between negative 6, which includes negative 6, and 5, but not including 5, that the y value is always 5. So in that case, h of negative 6 is just 5. Now for h of negative 3, we're looking for the x value where negative 3 would be, or the interval, or the domain restriction. And that is in here once again, because if you were to count from negative 6 to 5, just counting by ones, to be negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, blah, 1, 2, 3, 4, 5, 5 not included. But negative 3 is in there, and once again it's that same y value, so that answer would be 5 also. Now for h of 5, we want to find where x is 5. And since it's equal to 5 here, what we're going to do is we're going to replace the x with a 5 and find 5 plus 6. I probably should be using correct notation. In fact, I'm just going to do it right here. So it's going to be take x plus 6, so that's the a function we're going to use, the piece of the function we're going to use, and replace the x with a 5. And 5 plus 6 is 11. So for h of 9, we're going to use that same piece of the function because 9 is greater than 5. And so for that case, we're going to use x plus 6, replace the x with the 9, and find 9 plus 6, which is 11. And that's all it is. These domain restrictions are the most important part of a piecewise function when it comes to finding function values. Let's graph this piecewise function. Now it's called piecewise function because it is divided up into two different pieces. The first piece is 1/2 x, where x is less than 0. So I'm going to use my graphing calculator. I'm going to hit y equals, I'm going to type in 1 divided by 2x, then hit graph. Now it is a line, so there's a couple things I can do. What I'm really going to do is just look at the table because of the 0, x less than 0. Since it is less than, that means that I'm looking at from 0 and then to the left, because that's all the x values less than 0 go to the left of 0. So when I look at my table, I'm just going to pick a couple of these points. 0, 0 is the main one I'm going to look at. Now when I do put the 0, 0 point, I am not going to draw a closed circle, I'm going to draw an open circle. The reason why it's open is because it's less than 0, it's not equals to it, so that's an open circle. And then -2, -1 is here. And then I just keep on looking, -4, -2. So that's an open circle. Connect the dots, going to the left. And now I'm going to graph x plus 3. X plus 3 is a line that goes through the y-axis at 3. So let's look at our table. Notice we're looking at the domain restriction of x greater than or equal to 0. So I want to look at 0. And that point is 0, 3. So what that means is I'm going to go to 0, 3. And since the 0 is included, because of the equal sign, I'm going to put a closed dot. And then I can plot 1, 4, 2, 5, so on, so on, so on. And then connect the dots. Notice, closed, open, because of the domain restriction. Now I'm going to try something right now. You're probably not going to like it, so you may not want to watch the rest of this, because what I just shown you was probably the easiest way to do it. But you can do things like this. And I'm just experimenting right now. See what I did? If I look at the table, it's kind of confusing when I look at the table, because all those are zeros. It just means that my last point I'm looking at is 0, 0. And what I did when I typed it in, I did 1 divided by 2x, which is the standard equation that's given, and then x less than 0 I typed in for the domain restriction, and that less than is found underneath the test key, which is second math. So let's go back to y equals and hit enter. Let's type in x plus 3. Then in parentheses I'm going to put the domain restriction, x, and then second math, greater than or equals to is 4, 0, and then graph it. So it gives us something strange. So let's see if I insert parentheses around the x plus 2. I should be x plus 3, by the way. See if that does anything. Yeah. So, the moral of the story is, if you are going to use this, be very, very careful. You probably want to put everything in parentheses. And you look at the graph, and you should see something similar to what you've drawn. The thing is that this graph is going to connect those two right here. You can't see it, but if it were out over, you would connect it, and you don't want them connected. So you have to be really, really careful. That's why you want to look at the endpoints of your domain restriction 0, 0. So if I look at the table, you can see 0, 0 is for this equation, and then 0, 3 is for this equation. So I think I might not do this, but if you're someone that's adventurous, you might want to look at it. Let's graph this piecewise function. Notice we have the domain restrictions. Then we're going to use those to graph each piece. And I may even use a graphing calculator to help me out a little bit. I think it's going to be easier that way. So let's start with the first piece, which is f of x equals x plus 1 for x less than or equal to negative 5. So I'm going to go to my graphing calculator and go to y equals, because f of x is the same as y, in case you're wondering. I'm just going to type in x plus 1, then graph. Now, this negative 5 is an important number. I'm going to use that to determine a point to plot. So if I were to do this by hand, I would take the x plus 1 and find negative 5 plus 1, which is negative 4. I could just do trace negative 5 and then hit enter and see that negative 4 also. So what that means is that I have one point, negative 5 comma negative 4. So I'm going to go left 5 and down 4 and plot that point. Now if I want to, I can go to my table or just substitute like a negative 6 in there. If I do negative 6, I will get negative 5. But you can look at your table, because I need to go, since this is x is less than or equal to negative 5, I need to go less than negative 5. So that means negative 6 and negative 5, which is that point I've already mentioned. So if I look at the graph, what I'm going to do is I'm just going to connect the dots, or extend the line, I should say. Now the only question that remains is this point a closed circle like I have it, or is it open? And since it's equals to it, I'm going to leave it closed like that. So I'm going to clear that one out, and then we have, I'm going to erase this, just get this out of the way. For the second piece, we have f of x or y equals negative 3, and that's between these two values, negative 5 and 6. Now if you don't know how negative 3 looks, it's actually a horizontal line at y equals negative 3. So we're going to go down to negative 3, and notice we have negative 5, which is not included, and we have 6, which is not included. So I'm going to go down to negative 3, go over, I'm actually going to go over to negative 5, which is the x value, and go down to negative 3, and I'm going to put an open circle because it's not included. I'm going to go to x equals 6 and go down to 3 using the open circle because it's not included also. So these are your x values, and this is the y value. So y equals negative 3, so I'm graphing that horizontal line between negative 5 and 6, and not including those, but I am going to connect the dots. That's a nice straight line, isn't it? Now we have one more piece to do, and that's 1/2 x, and that's for x is greater than or equal to 6. Now, once again, I can use my graphing calculator to help me out a little bit. I like to use parentheses with fractions. You may or may not need to, it just depends on your calculator, but I like to just to be safe. And hit graph. And it's going to have a slope of rise 1, run 2, rise 1, run 2. What that basically means is I'm still going to plot points, but I'm going to start with the 6 because that's the number in my domain restriction that I'm considering. So if you throw in a 6, you're basically taking 1/2 times 6. How many times have I said basically in this video? Who knows? And you get 3. So what that means is that point is 6 comma 3. And once again, I can hit trace, 6, enter, and see that also. So I'm going to go right 6, up 3, and then I'm going to put a closed circle there. And the reason why it's closed is because the 6 is included. Now, if I need another point, which I do, I can always type in like 8, and I'll get an answer of 4. 8, 4, which would be that point, because I like to be pretty accurate. Once again, you can go to your table, and since this domain restriction is x equals 6, I need to look at every number bigger than 6. I don't want to use a fraction. I could though, or decimal. Let's just use 8, 4, and then notice greater than means everything that way. Let's see if I hit trace 6, enter. The good thing is that point pops up, and then everything bigger than that goes that direction. So that's just something to keep in mind also. And you get a function like something like that. My line's off a little bit. Let's make it better. Yeah, I can do that. Cool. And that's pretty much the graph of your piecewise function. I'm going to do something else. I think that with this, you can type in x plus 1 and then parentheses x. We're going to go to second math, which is the test key, looking for less than or equals to, which is 6, negative 5. And let's do the graph. Okay, that's not what I was expecting to see. So let's see if I can make it better. X plus 1. Some calculators you can do this, and it makes life a little bit easier. But this may not be one of those. We'll just see. I hit the wrong button. Number 6. Yeah, that's what I was looking for. Notice my mistake on the first part. I didn't put in the equation, the function, the piece in parentheses. So here's what I did. I'm going to do it again. I'm going to put the x plus 1 in parentheses. X plus 1. And I'm going to put the domain restriction in parentheses also. X. And that inequality is in the test key, which is above the math. So let's hit second math, and then number 6, and then type in the negative 5, close it, and just hit graph. And you'll see that part right there. If I go to the table, all those values, those don't exist. Those zeros are actually not part of the graph. But then you start seeing that negative 5, and you see a y value there. So there's a couple points you can use. And notice that negative 5 has a value of negative 4, which means it's included. And I can go to y equals, hit enter, then I can type in negative 3. I'm going to put that in parentheses just to be safe. And then put in my domain restriction, negative 5, second math, less than is 5, x, second math, 5, 6, close parentheses, and graph that. Well, it didn't do what I was hoping it would do. And it may be with this part that it won't do it. So I may have to do this. X greater than 6. No, x less than 6. What am I thinking? Yeah, learning new things all the time. So watch what I did. I separated this. I have negative 5 less than x. I'll cover that up. And then I have x less than 6. Sketch that. And so when I typed that one in, I had to separate it. It wouldn't let me do it all at once. So I had to separate that, just like that. See that? It's amazing how that happens. It just went crazy on me. It just does that on its own. But notice, I had to separate those two. Yep, things to keep in mind. Now, it's the last part. I'm going to do 1 divided by 2x, put that in parentheses, and then x, second math, greater than or equals 2, is 4, 6. And then graph that. You see the third part. See that? If I look at the table, you'll see now y2 represents this piece. This is that second piece. So you'll see those y values starting at -4. See at -5 it doesn't have one. With the zero, consider 0 is not part of the graph in this case. So -4 it does, and then all the way to +5 it does, and 6 it doesn't. So 5 and 6 are not included. Open circle. And then for greater than 6, I'm going to move it over. You'll see the y3 that although the 0 is before you get to 6, and when you get to 6 you'll see the y value of 3 which we found, and then from there you'll see the other one's 4, which represents this piece. So that's how you can do it on a graphing calculator if you want to check your answer.